basically a very intuitive idea that it is space spawned by a vector. So if you have a single vector, let's say this vector is I, okay, then all the vectors that is collinear to this vector, and this represents a vector space. So it's a linear vector space. So its vector space here in this case is line. Then all the vectors in this space, in this line, okay. So one dimensional vector space it is. Vector space, and all the vectors in this space will be represented in terms of this, okay. So if you take a vector which is in this space, then A can be written as k times I, okay. And in this similar manner, all the vectors that are there out there in this one dimensional space, that can be represented in terms of this vector. It doesn't really have to be unit vector, okay. It just can be any vector and then k times, and you can easily determine what the value of k is, okay, by taking a dot product of A with I, okay. We have already seen how to represent one vector in terms of other, isn't it? So similarly, you can have two-dimensional space. I mean, we have already seen this in our basic physics. So two-dimensional vector space is generally characterized by two unit vectors I and j, and any vector that is here in this two-dimensional space A can be represented in terms of I and j, isn't it? So A will be represented like k1i plus k2 j. Okay, what is k1 here? K1 is basically A dot I divided by I dot I, isn't it? So we already know. I mean, we can make some caps here and okay, if you want so desire, but otherwise it's fine by me. Okay, so we already know all the vectors in two-dimensional vector. जो IJ प्लेन में है उनको आप IJ यूज करके यूनिट वेक्टर यूज करके एक्सप्रेस कर सकते हैं. कोई भी ऐसा वेक्टर है इस प्लेन में जो एक्सप्रेस नहीं होगा I और J के टर्म में, which lies in this plane and cannot be expressed in terms of I and J?
No.
Okay, so all these vectors can be represented, isn't it? So let's say that we have a three-dimensional space here, and this is the third vector space that I'm talking about. And this is the only three vector space that you can actually visualize. Okay, so I, and let's say this is J, and this one here is K. Okay, so all three-dimensional vector in the world can be represented in terms of this ij and k only, isn't it? So let's say that you have a vector A, which is somewhere here, and this A vector can be written as k1 I, isn't it? Plus k2 j plus k3 k, right? Now, what is now let's just examine this a bit closely. Okay, so what is it that you see here? Okay, आपको यहाँ पे क्या दिखता है? What is the relationship between I, J and K?
They are perpendicular to each other.
They are orthogonal to each other, isn't it? So they are orthogonal to each other. So they are pairwise orthogonal. I is orthogonal to J and K, J is orthogonal to I and K, K is orthogonal to I and J, isn't it? Right? So if you have orthogonal set of vector, I'm not talking about that they are the fact that they are unit vector, okay? But if you have orthogonal vectors, then you can easily express any function, any vector that is there in terms of that orthogonal vector set, isn't it? ये थ्री डायमेंशनल वर्ल्ड में कोई भी ऐसा वेक्टर नहीं है जो आई जे और के टर्म में न रिप्रेजेंट हो, राइट? यू कैन ऑलवेज फाइंड आउट कि कोई भी वेक्टर है आप इसको इसके टर्म में निकाल सकते हैं. इज दैट क्लियर टू एवरीवन?
Yes, sir.
So all we need to do is find out these orthogonal vectors, isn't it? अगर हमारे पास ये I हो, जे हो और के हो, मतलब ऑर्थोगोनल वेक्टर्स हो। किस थ्री डायमेंशनल स्पेस में आपको थ्री ऑर्थोगोनल वेक्टर चाहिए, फोर डायमेंशनल स्पेस में आपको फोर ऑर्थोगोनल वेक्टर चाहिए। अगर आपका इनफाइनाइट डायमेंशनल वेक्टर स्पेस हो तो कितने वेक्टर चाहिए आपको? इनफाइनाइट वेक्टर चाहिए, इजंट इट? Is
Yes.
that clear? Okay.
Yes, sir.
Now, let me just tell you that there is already a vector space in functions like this. So there are many actually, but we are going to see some of the basic one. Okay. So one such vector space is 1 cos, sorry. So I'm talking about, functions are generally what is called as, they are infinite dimensional vector. What is functions? Functions are, let me, to be precise, let me write, signals are, signals are infinite dimensional vector. Vector, right? Is that clear? So we need infinite basis vector. So these I, J and K are called basis vector. इनको क्या बोलते हैं हम लोग? Basis vector. Okay. I, J और K जो है ये बेसिस है, क्योंकि इन्हीं के बेस पे हम सबको रिप्रेजेंट कर पा रहे हैं. एनी वेक्टर इन दिस फील्ड can be represented using these basis vector, isn't it? So we call this basis vector. So we have some infinite dimensional vector orthogonal vectors in signal space as well, because signals are infinite dimensional. So we need infinite vectors there, okay, to represent a function in terms of that. But once we have that, we can represent any function in terms of that only. Okay. So between, again, let me just write this, between time 0 to t naught. Okay. I'm talking about this finite dimension time only. Okay. And between this finite duration of time, we already have a vector space like basis vector space like this. So basis signals, let me call them. So basis signals between 0 to t naught are 1, and then you have cos n omega naught t, and then sine n omega naught t. Okay, where n varies from, n is 1, 2, 3, all the way up to infinity. So basically what n is element of positive integer, isn't it? So we call this z plus. Okay, integers को z लिखते हैं, positive integers हैं. Or you can call this n is element of natural number as well. Okay, तो ये natural numbers है, right? 1 to infinity. Is that clear? And you can easily prove this. It's not difficult. Okay, and here what is omega naught? Omega naught is equal to 2 pi by t naught. Is that clear? Is it clear to everyone? So this here is a basis vector. And now if we have any signal that is defined between, and let me prove that all of them are orthogonal, okay? So I mean, n की किसी भी वैल्यू के लिए मैं प्रूव कर सकता हूँ. तो let me just see this dot product of 1 and cos omega naught. Sorry, cos. Let me just write this. What will be dot product of 1 and cos omega naught? N omega naught t. Can anybody tell me what this dot product is going to be for any value of n? So this is, we are trying to find out dot product between period 0 to t naught, isn't it? So what this is going to be? It's defined at integration between the time interval 0 to t naught. This signal times complex conjugate of other, but both of them are real. So complex conjugate will be the same signal, isn't it? So this is basically 1 times cos n omega naught t, isn't it? And dt. यही होगा. will you be getting the same thing or not?
Yes.
Okay. And what is this? This is basically 0 to t naught cos n omega naught t dt. What will be this value? Can anybody tell me? Okay, just tell me what is the fundamental period of this cos n omega naught t. So its fundamental period is equal to what?
And
T naught by n.
yes, sir. Not
2 pi by omega naught. So here is 2 pi by omega. So what is omega here? N omega naught, isn't it? So 2 pi by n omega naught, isn't it? And we know that 2 pi by omega naught is equal to t naught. So this is actually, let me just write this 2 pi by n omega naught. And we already know that 2 pi by omega naught is how much? T naught, isn't it? So it is t naught divided by n. Is that clear? What does that mean? कि हम लोग क्या कर रहे हैं? And what is n? N is integer, isn't it? N is a natural number, means it is a positive integer, right? So how many cycles are you integrating here? N cycles. इसमें 0 to t naught में कितने साइकिल आएंगे cos n omega naught t के?
n, sir.
N साइकिल. एक साइकिल का कितना होता है एरिया? cos के एक साइकिल का एरिया कितना होता है? cos इस तरह से होता है ना?
0.
सॉरी 0, राइट?
0.
यानी n साइकिल का एरिया कितना होगा? n times 0, that is equal to 0. Are you getting me? I got this without even using anything, isn't it? I didn't really do integration and I arrived at, but you can do this integration and you can find the same value. So cos n omega naught का integration क्या होगा? Sin n omega naught t divided by n omega naught, isn't it? And you will be putting the value 0 to t naught. And you will see that this is basically 1 by n omega naught. Let me take that here, and what you will be putting? Cos of n omega naught t. So this will be basically cos of n omega naught t naught, on omega naught t naught is equal to 2 pi, isn't it? Cos n times 2 pi and minus cos of 0, which is equal to 1. And what is cos of n times 2 pi? It is also 1, isn't it? So what you are getting is n omega naught 1 minus 1, and that is equal to 0. So no matter how you are going to do, you will be arriving at the same result, and that is 0. But what this implies here? So this means this term is equal to 0, isn't it? Right? और ये टर्म क्या है? 1 और cos n omega naught t का क्या है? डॉट प्रोडक्ट है, राइट? एंड व्हाट डज दैट इम्प्लाइज? कि अगर डॉट प्रोडक्ट दो सिग्नल्स का 0 है या दो वेक्टर्स का 0 है, तो हम क्या बोलते हैं उन वेक्टर्स को या उन सिग्नल्स को क्या बोलते हैं?
Orthogonal.
Orthogonal. So I proved that 1 and cos n omega naught t for every value of n, for n is equal to, I'm not considering a particular value. Okay, I'm saying that n is any integer here, isn't it? So for all integer value of n, these two are 1 and this are orthogonal, isn't it? Is that clear to everyone?
Yes, sir.
Okay. Similarly, you can, I can go ahead and similarly, you can easily prove that this 1 and sine omega naught, sine n omega naught t are also going to be orthogonal. You can say easily, isn't it? Sine n omega naught orthogonal होगा कि नहीं होगा? आप
Yes.
देख सकते हैं, this is going to be 1
Yes, sir.
dot sine n omega naught t, and this will be equal to basically integration between 0 to t naught, 1 times sin n omega naught t, which is basically sin n omega naught t. And sin के कितने मिलेंगे आपको इसमें साइकिल्स, n साइकिल्स मिलेंगे, isn't it? और एक साइकिल का एरिया 0 है तो n साइकिल का एरिया और भी क्या होगा, 0 होगा. Is that clear? So this is basically equal to 0. You can easily do this. Now let's come to the good part here. Let me say that if we have cos m omega naught t, and I have another signal which is cos, but some other integer, let's say n, okay, omega naught t. Are they orthogonal or not? Will they be orthogonal or not between time 0 to t naught? That is the next question, and we can investigate that. So this will be equal to how much? This will be equal to 0 to t naught, right? Integrate करते हैं हम लोग दोनों को multiply करके, यही है ना dot product.
1.
So this will be cos m omega naught t times cos n omega naught t and dt. So what is it basically? Cos a into cos b, isn't it? So cos a into इसको what we can write this 2 cos a and we can divide it by half, isn't it? Let me do that in different colors so that it should be clear to you. So we can divide it by half. Sorry, sorry. So this is half here, and let me 2 cos m omega naught into cos n omega naught t. ये फॉर्मूला मालूम है आपको कितना होता है? Can anybody tell me what this is going to be 2 cos? 2 cos A into cos B कब आता है? So this will be equal to cos A plus B. Cos क्या है ये? यहाँ पे क्या फॉर्मूला यूज करेंगे हम लोग? 2 cos A into cos B, isn't it? कब आता है 2 cos A into cos B?
Cos A plus B plus cos A minus B.
Cos A plus B into cos A minus B. So what we will be getting is cos m plus n, isn't it? Omega naught t and dt here, and plus we have another part that is 0 to integration t naught, and what this is going to be cos m minus n and omega naught t, and then you will have dt. Is that clear? Right? यही आएगा ना हमारा. दो अलग अलग इंटीग्रेशन मिले. मुझे बताओ इसका वैल्यू क्या होगा और इसका वैल्यू क्या होगा? What is these values are going to be? So you see that here you will be getting m plus n cycle between 0 to t naught, isn't it? फ्रीक्वेंसी m प्लस n टाइम्स है इसके फ्रीक्वेंसी की, ओरिजिनल फ्रीक्वेंसी क्या. इसका मतलब क्या है? टी नॉट कितना होगा? m बाई n टाइम्स कम होगा, यानी m प्लस n साइकिल्स मिलेंगे एक साइकिल में. So we are basically getting m plus n complete cycle of cos m plus n omega naught t between 0 to t naught. And here we are getting complete m minus n cycle of cos n m minus n omega naught t. तो ये cos ही है basically, isn't it? So complete cycle का एरिया कितना हो जाएगा? 0 ही होगा. Or do we have any reservation about that?
Sir, 0 ही होगा.
0 होगा, right? So can I say? So can I say that these two are orthogonal as well? तो मैं कह सकता हूं.
Yes, sir.
So cos m omega naught t and cos n omega naught t are orthogonal. And the same thing you can apply for sine as well. Okay, so sine m omega naught t and sine m omega naught t are orthogonal as well. Okay, is that clear? You will आपको क्या मिलेगा यहाँ पे साइन को अगर मल्टीप्लाई करोगे you will again end up with what cos m plus n omega naught t, यहाँ पे प्लस की जगह माइनस होगा, isn't it? होगा कि नहीं? फॉर्मूला में बस इतना ही चेंज है ना. So we'll still end up with these two terms. Instead of plus you will be getting minus there. So what, वो भी क्या होगा, जीरो ही होगा. Do we all agree on this? Okay.
Yes.
So now we just have one set, and that is sine n omega naught t and cos m omega naught t. Right? Whether their dot product will be zero or not. So we'll see that their dot product is also going to be zero. Why they will be zero? Sine into cos. You will again write 2 sine and divide by half. 2 sine into cos, and that is equal to sine a plus b into sine a minus b. तो यहाँ पे इस इंटीग्रेशन में cos की जगह पे क्या मिलेगा आपको? साइन ए प्लस बी एंड प्लस साइन ए माइनस बी. साइन के भी एक कंप्लीट साइकिल का एरिया जीरो होता है, तो दिस इज स्टिल गोइंग टू एंड अप विद जीरो, and these two are also orthogonal. Okay, so we have in short proved that all the signals here in this set, and the set, let me write this one, and what we have, cos omega naught t is the first one here, and then what we have, multiple of it, so cos 2 omega naught t. तीसरा क्या होगा हमारा, cos, सॉरी चौथा है ये, cos क्या होगा, ये 3 omega naught t, isn't it? And this is going to continue all the way. And similarly we have what, sin omega naught t, उसके बाद क्या है, sin 2 omega naught t, and क्या है, sin 3 omega naught t. Okay, dot dot dot, all these are equal to what? These are all orthogonal, isn't it? So this here is a orthogonal set. Gonal set of signals between time. I have taken 0 to t naught, but it can be any time period of t naught. Okay, is that clear?
सर वो जस्ट ऊपर वाले एग्जांपल में इस फंक्शन खुद के साथ ऑर्थोगोनल कैसे हो सकता है?
कौन सा सिग्नल खुद के साथ ऑर्थोगोनल है? मैंने खुद के साथ कहाँ लिया है? मैंने आप ये cos m ओमेगा नॉट और cos n ओमेगा नॉट दोनों अलग है ना?
सर मैंने वो थर्ड वाला लिखते गलत लिखते हैं, वो cos की जगह sin लिखते।
ओके 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 ओके, खुद के साथ खुद का डॉट प्रोडक्ट करोगे तो तुमको मिलता है जो उसको बोलते हैं ईटी नॉट स्क्वायर मिलेगा, ईटी नॉट मिलेगा, एनर्जी मिलेगा तुम्हें. आर यू गेटिंग माय पॉइंट? 0 to t naught, and what you will have is this function itself is square, isn't it? f of t whole square dt. और इसको क्या बोलते हैं हम लोग? ई टी नॉट, एनर्जी बिटवीन टाइम 0 to t naught. Is that clear?
Yes sir.
Okay, so don't worry about that. I mean, it's happens. Okay, हम लोग ध्यान नहीं देते हैं तो, but you can even take my word that each and every one of them are orthogonal. Even so, if we have any function that is defined, so what does this basically means? That we have a orthogonal basis set of vector, isn't it? इसका मतलब क्या है कि हमारे पास एक orthogonal set of vectors है, isn't it? Right? So it means we have our basis vector. And if we have our basis vector, this we can express any function that is defined between 0 to t naught. So let's say that I have a function ft, which is defined as like this, that it is equal to, let me draw this और उसके बाद मैं define कर लूँगा. Okay, or let me, instead of ft, let me call this ft naught under bracket t. Okay, subscript t naught is there. That means that it is defined between, let's say area, uska jo duration hai wo kya hai, t naught hai. That all it means. Okay, so our function is, let me say that it is something like this. It's 1 for half of the duration and it's 0 for the next half of the duration. Okay, so let me do this in red color maybe, so that it should be clear that it is actually 0. And this signal is defined between 0, this point in 0, and this point here is t naught. And let's say this point is t naught by 2. I'm just exactly going to make this a symmetric, okay, kind of symmetric. Okay, is that clear?
Yes.
So if we have a function like this, okay, we can represent this in terms of these basis vector, isn't it? Right? अभी मैंने क्या बताया कि अगर हमारे पास ऑर्थोगोनल सेट ऑफ वेक्टर है, कंप्लीट सेट ऑफ वेक्टर, then we can represent any vector that is there in terms of those orthogonal vector. So we have this orthogonal set of signals, or what you can say vectors. Signals means vector. Okay, signals between time 0 to t naught, and we have a signal which is defined between time 0 to t naught. So can we represent this ft naught in terms of these functions? Can I do that? Of course I can do that, isn't it? This is what our vector decomposition means. Vector decomposition हम लोग यही सीखते हैं. It means we can represent this f subscript t naught of t, okay, by writing like it. We will write this like a naught. Uh, let me write down my functions first, and then I will do this. Okay. So okay, so I can write a naught, and then we will have plus a1, and then I will have plus a2, and then I will have plus a3, and this is going to be dot dot dot, isn't it? And let me just do this. So this will be a naught 1, and here we will have cos omega naught t. Here what we are going to have, cos 2 omega naught t. Here what we will have, cos 3 omega naught t, isn't it? And similarly we can write it like this here, plus b1 plus b2 plus b3, and then we will have dot dot dot, and here we can write this as sine omega naught t, sine 2 omega naught t, and sine 3 omega naught t, and it's going to continue forever, isn't it? We have infinite number of cosine and cos or sine, isn't it? Is this clear to everyone? And what is a1 and a0? I mean, as I told you before, that when we were representing, let me just write it here only, okay, so that you can get that value. Okay, let me make a square bracket here so that you can understand that it's a kind of other discussion. So we had a vector a, we were representing how, like this, we were representing a1 times I, isn't it? And then we were representing it a2 times j, isn't it? And a3 times k. What is a1? a1 is scalar multiple, isn't it? So a को अगर हम एक, so what is a1? You can write a1 as a dot I divided by I dot I. ए अगर इसमें आप ये दोनों तरफ a का सॉरी I से डॉट प्रोडक्ट ले, so what you will be getting? You will be getting a1, isn't it? Are you getting my point? A dot I, और इधर डॉट प्रोडक्ट लोगे तो I j dot I will be 0, k dot I will be 0. So you will be left with a1 dot I. A1 times, I mean, it's not dot actually, it's just a scalar. Scalar means it's just a number, isn't it? Is that clear? ये यहां तक समझ में आया है सब लोगों को कि नहीं? Hello?
Yes, sir.
Okay. So here again, we can compute our A naught. And I mean, let me just write this in a shortcut notation. That will be better for us. So we can write this as, let me write this again. A naught times 1 means A naught only. And then summation, this is n is equal to 1 all the way up to infinity. What we have? An cos n omega naught t, right? And then we have what? Bn sine n omega naught t. Is this clear? I mean, I have written it in shortcut form because we can't really, infinite time है तो उतना time तो मैं लिख नहीं सकता, right? And what will be A naught according to the formula that I have just discussed here? Our A naught will be dot product of what? So A naught here is, let me just write this in blue color. So A naught will be basically what? This ft naught t, okay, dot how much? ये 1 के साथ है, right? So basis vector here is 1, isn't it? So f naught ft naught times 1 dot product divided by 1 dot 1, isn't it? यही होगा ना? Are you getting my point?
Yes.
Okay. So ये जो ऊपर वाला डॉट प्रोडक्ट है वो क्या होगा बताइए मुझे. This will be what? 0 to t naught. और ये क्या होता है? f t naught t times 1. और times 1 मतलब क्या? वही सिग्नल, right? dt. Isn't it? And this divided by how much? Integration between 0 to t naught. 1 times 1 means 1 dt. Tell me what this denominator will be equal to. So A naught turns out to be what? What will be this denominator? Can anybody tell me? ये इंटीग्रेशन कितना होगा? 1 को आप इंटीग्रेट कर रहे हैं कांस्टेंट 1 को 0 से t नॉट के बीच में, तो कितना मिलेगा आपको आंसर? t नॉट, राइट? सो व्हाट यू गॉट इज 1 by t नॉट 0 to t नॉट f t नॉट t d of t. And if you remember from your earlier classes, दिस बेसिकली इज फूरियर. आई मीन ए नॉट की वैल्यू वहां पे यही आती है, यही आता है कि नहीं आपका? आप लोगों ने पढ़ा होगा फूरियर सीरीज, तो उसमें यही वैल्यू निकाला होगा ए नॉट का. यू मस्ट हैव स्टडीड इन सेकंड सेमेस्टर, isn't it? Similarly, you can compute the value of an. So what will be an? An will be what? Dot product of ft times ft with cos n omega naught t, isn't it?
Yes, sir.
Divided by dot product of cos n omega naught t with cos n omega naught t only, isn't it? Right? So ऊपर वाला क्या देगा हमें? 0 to t naught. And what this is going to be? ft cos n omega naught t, right? dt. और नीचे क्या मिलेगा आपको? 0 to t naught cos n omega naught t को cos n omega naught t से मल्टीप्लाई कर रहा है, तो कितना हो जाएगा? cos स्क्वायर n omega naught t, isn't it?
Yes, sir.
Cos square n omega naught t dt, and this can be converted in terms of cos 2a, isn't it? So how much this can be written? I can write it like this. It is 1 plus cos 2n omega naught t, and this whole thing divided by 2, right? Let me do that later, okay? यहाँ पे मैं cos square and not omega naught t लिखता हूँ, so that you should remember what are the cos square and omega naught t. This is very simple integration, and let me just give this value. So we are computing 0 to t naught cos square n omega naught t dt, and this will be equal to 0 to t naught. As I told you already, this will be half dt plus 0 to t naught. Half again we will have, and we will have cos 2n omega naught t dt. What will be the first part? What will be this? हाफ को आप 0 से t नॉट के बीच में इंटीग्रेट करेंगे तो कितना मिलेगा हमें? Can anybody tell me?
T naught by 2.
T naught by 2. Thank you very much. And if you integrate this part here, what that is going to be equal to? Again you realize
0.
cos n, this is cos 2n omega naught t, right? तो इसके 2n साइकिल्स हैं 0 से t नॉट के बीच में. एक साइकिल का एरिया 0 है, यानी 2n साइकिल का भी एरिया कितना होगा? 0. Right? And let me just conclude here. So our an turned out to be how much? This 0 to t naught f t naught t, sorry, f t naught t cos n omega naught t dt, right? And this divided by t naught by 2, right? तो इसको हम लोग इस तरह से लिखते हैं 2 by t naught 0 to t naught this f t naught t cos n omega naught t dt. Is that clear? And this is what an is. I hope that this is clear to all of you. If you have any confusion or any doubt, you can, बेझिझक पूछ सकते हैं, okay? Should not take confusion from the class, okay? So we have calculated an. In the similar manner, we can also compute bn, isn't it? So what is going to be our b1? Bn will be what? Dot product of f t naught t with what? Sin n omega naught t, isn't it? And this divided by how much? Sin n omega, because this is the basis vector, isn't it? Sin n omega naught t with sin n omega naught t, right? So this top part is going to be 0 to t naught, this f t naught t sin n omega naught t dt, and divided by क्या हो जाएगा? 0 to t naught, how much? Sin square n omega naught t dt. Is that clear? So what we will be having 0 to t naught. So let me just find out this denominator value. So what this is going to be 0 to t naught sin square n omega naught t dt. And if I do this, we already know that this is basically 1 minus cos 2, हाँ 1 minus cos, सर cos 2n बराबर क्या हो जाएगा? 1 minus 2 sin square. So yes, 1 minus क्या होगा ये? Cos 2n omega naught t, right? होगा ना, divided by 2. And we are integrating this 0 to t naught and dt. So what we will be ending up with kind of the same thing, isn't it? So now we are integrating 0 to t naught, half dt here, and then minus 0 to t naught and half, let me take outside, and cos n, sorry, 2n omega naught t dt. And we already know that this value is equal to t naught divided by 2, and this value is equal to minus. So this also turned out to be t naught by 2. Okay. And that is actually pretty much easy. You can, without integration भी आप लोग निकाल सकते हैं. But okay, but I didn't wanted to do that. Here I just wanted to be a bit more formal. So Bn turns out to be here in this case equal to how much? 2 by t naught 0 to t naught f t naught t sine n omega naught t dt. So I hope that this is also clear to all of you. Okay. Right. So आपको अभी समझ में आ गया कि फूरियर सीरीज क्या है? वेक्टर डिकम्पोजिशन की तरह है। जैसे किसी भी वेक्टर को आप लोग डिकम्पोज करते हैं आई जे के टर्म में, आई जे के जहां हमारा बेसिस वेक्टर है, उसी तरह से हम किसी भी वेक्टर को क्या कर रहे हैं? डिकम्पोज कर रहे हैं किसके टर्म में? 1 cos n omega naught t और sin n omega naught t. And this is not the only Fourier series that is there, because all you have to do is change your basis vector. तो अभी आप लोगों ने पता नहीं पढ़ा है कि नहीं, वो शायद अभी इलेक्ट्रोमैग्नेटिक्स और कई जगह पे आप पढ़ेंगे कि वी हैव डिफरेंट टाइप ऑफ ऑर्थोगोनल वेक्टर, इजंट इट? आई जे के हम लोग लेते हैं किसमें? रेक्टेंगुलर कोऑर्डिनेट सिस्टम में, है ना। अभी सर्कुलर कोऑर्डिनेट सिस्टम में कुछ और लिया जाता है, आर थीटा फाई, इजंट इट? लेते हो ना। और रो फाई और जेड लेते हैं हम लोग किसमें? सिलिंड्रिकल कोऑर्डिनेट सिस्टम में. सो all we have to do is change our coordinate system, and there are lots of orthogonal vector sets which are orthogonal between, which are, all of them are orthogonal between 0 to t naught. Okay, and simplest one of them is this one cos n omega naught t sin n omega naught t, और इसीलिए ये पढ़ाया जाता है. ठीक है, साइन कॉस से स्टार्ट किया जाता है इसी वजह से. A second time of vector, this vector decomposition in terms of Fourier series, you will see is in terms of e to the power j omega naught t or e to the power j n omega naught t. So n can be here from minus infinity to infinity, all the integers. So minus, from minus infinity to plus infinity, every integer in between. Okay. So that is also a orthogonal vector set, and you will see that हम लोग वो भी पढ़ने वाले हैं. एंड इसके अलावा आप लोगों ने वो कौन सा फंक्शन पढ़ते हैं? बेसेल्स फंक्शंस आपने पढ़ा है. So there is a Fourier series that can be defined in terms of Bessel's function. There are Fourier series that can be defined in terms of sinc and shifted sinc functions. Okay. So there are lots of different kind of Fourier series that you can see, but all of them are not equally useful, because as the basis functions get more complicated, the meaning of the usefulness of Fourier series is kind of lost. But again, we can do that. It is possible. In fact, the first paper on what you guys sampling is a very बहुत ही इम्पोर्टेंट टॉपिक है. आप लोगों ने पढ़ा भी होगा सेकेंड ईयर में, या कम्युनिकेशन में भी पढ़ा होगा, डीएसपी वगैरह में भी पढ़ा होगा, सिग्नल सिस्टम में भी शायद मैंने थोड़ा बहुत बताया होगा अगर मैंने पढ़ाया तो. तो सैम्पलिंग का जो ओरिजिनल पेपर है, इन दैट पेपर दे हैव प्रूव्ड सैंपल्स, कि सैंपल से आप रिकवर कैसे करेंगे. सो एट दैट टाइम व्हाट दे हैव यूज्ड द फूरियर सीरीज इन टर्म्स ऑफ सिंक फंक्शन ओनली. ओके. And that's why interpolation formula that you may have studied or may have seen contains the term sinc there. If you are confused, then that's where it came from. Okay. Is that clear? So what we are doing is हम लोग signal decomposition कर रहे हैं Fourier series में. And as our basis vector here, in this case, our basis vectors are 1, है ना, ये 1 है, और क्या है? cos ओमेगा नॉट, cos n ओमेगा नॉट है बेसिकली, फॉर वैल्यू ऑफ n फ्रॉम 1 to infinity, and then we have sin n omega naught, sin omega naught t, sin 2 omega naught t, so on and so forth. Okay, so is this clear to everyone?
Yes, sir.
Okay, now let's address another thing that I think that should be clear to you, and that is that our ft naught t is now equal to a naught plus an sine, an cos, I always do this, a1 cos n omega naught t plus bn sine n omega naught t And I mean, I forgot the summation. Let me do that here. Let me write equal. इसको थोड़ा सा पीछे करना पड़ेगा. Okay. So equal to a naught plus this. There should be a summation sign here. N is equal to 1 to infinity. ये लिख रहे हैं, right? Is that clear? And ft naught is a signal that is defined between what? 0 to t naught. ये कहां से कहां तक डिफाइंड है? 0 से t naught के बीच में, राइट?
यस सर.
ओके. एंड राइट साइड में जो हमारे पास सिग्नल है, व्हाट इज दैट? क्या है ये? सो वी हैव टू पार्ट ऑफ दिस. वन इज दिस राइट हैंड साइड. लेट मी जस्ट डू दिस, कंट्रोल दे. एक राइट साइड है, एक लेफ्ट साइड है. तो लेफ्ट साइड क्या है? 0 से t naught के बीच डिफाइंड है. और फूरियर सीरीज के हिसाब से दिस सिग्नल इज इक्वल टू दिस राइट हैंड साइड बिटवीन 0 टू t naught. बट राइट साइड में जो सिग्नल है cos ओमेगा नॉट t या कांस्टेंट 1, they are, I mean, from minus infinity to infinity, isn't it? Cos n omega naught t. अगर मैं पूछूं आपसे कि cos थीटा का या cos t का डोमेन क्या है, तो आप क्या बोलेंगे? डोमेन कितना है? माइनस इंफिनिटी टू इंफिनिटी है, राइट? Isn't it?
Yes.
So we have a left-handed signal, which is basically confined to 0 to t naught, which is a finite duration signal. It means it is a finite duration signal. Isn't it? And on the right hand side, we have this signal. I mean, this whole thing. Let me kind of put it in a box here so that to better सॉरी, मेरी आवाज आ रही है आप लोगों को?
Yes sir.
एक्चुअली बहुत तेज बारिश होने लग गई तो कॉलेज का नेटवर्क जो है वो चला गया है. तो आई एम गोइंग टू कनेक्ट थ्रू माय मोबाइल. Okay, and then we will see how much long it's going to last. But I will try to go ahead with half an hour more discussion. Okay, so just wait for like 2 to 3 minutes. It will take me that much time to configure my laptop with this mobile. Okay. Okay. Am I audible? Can anybody confirm?
Yes sir, you are.
Okay. So I think my this is also visible. Screen is visible, right? अभी दिख रहा है आप लोगों को?
Yes sir.
Okay, so this is what I was talking about, that left hand side signal is finite and right side signal is infinite duration. और बोले कि चलो ठीक है कि between time 0 to t naught this right hand side is equal to left hand side. But what about the rest of the time? Okay, are you getting my point? कि अगर लेफ्ट साइड जो है आपका फाइनाइट ड्यूरेशन है, सो लेफ्ट साइड सिग्नल वाज लाइक दिस. लेट मी प्लॉट दैट अगेन. पता नहीं, sorry, let me plot it with the scale that I used before. So left side signal is defined between 0 to t naught, and let me just do this from all the way from here. Okay, so this is the time scale, and let's say between 0 to t naught our signal is defined between 0 to t naught, and from 0 to t ये कुछ इस तरह का था सिग्नल हमारा जो हमने किया था. So this was t naught by 2 and this is t naught. Okay. Now between this is our signal f t naught t. Okay. And let me just copy this, and because I will be using this. Okay. Proper copy नहीं हो रहा है. Okay. So anyway, let me just do this over this only. So this is f t naught t. But what about, let me इसके just नीचे ही स्केल में मैं ड्रॉ कर देता हूँ यहाँ पे. Okay, what about the right hand side? So this is left hand side, and what about right hand side? How the right hand side is going to be? So it turns out that between time 0 to t naught it is exactly like this function. So let me do this in a different color here. Okay, it is exactly like this function between 0 to t naught. But after that time, what it is sorry, it's kind of replication. Oh, sorry. Let me just do this properly here. What was it like? Control Z. Okay. Control C. Let me do this Control V. And it's like this, that it is kind of periodic repetition of this. Okay. Is that clear to all of you? So let me just do this periodic repetition in finite time. Okay. Something like this. And then let me do this Control V again. And we will have on the left hand side here as well. So just a bit. Okay. And then let me do this Control V again. And so you got this कि हमारा जो right hand side है वो क्या है? Periodic signal है. And its fundamental period is exactly like ft naught t. Isn't it? So I cannot draw it infinite time. So let me just put continuation mark here to describe that it is kind of ये जो है ये fundamental time में तो वैसा ही है, लेकिन उसके बाद क्या है उसका periodic repetition है. So this, let me call this as ft. So this ft is basically periodic repetition of this signal. So this is from n is equal to minus infinity to plus infinity f t naught t minus n t naught, where n is from minus infinity to infinity. So you can see you are basically repeating this, shifting and repeating, shifting and repeating. So what you have here, right hand side जो आपका है वो क्या है? That is basically a periodic signal, isn't it? So given a periodic signal, so this ft is what? Periodic signal, isn't it? ये क्या है हमारा? Periodic signal है. Okay, and so this is how the Fourier series is basically said. So maybe आप लोगों ने मैथ्स में वो 0 से t नॉट के बीच में ही रिप्रेजेंट करते हैं या 0 से x के बीच में रिप्रेजेंट करते हैं, जैसे भी करते हैं. So they are kind of discussing the original thing only, okay? But then after that, we say that what is about right hand side, and right hand side is like from defined from minus infinity to infinity. So what that is going to be like? So that turns out to be a periodic signal, isn't it? And if it is a periodic signal, तो हम लोग क्या बोलते हैं कि if ft is equal to, instead of ft naught क्या लिखते हैं, ft is equal to a naught plus summation n is equal to 1 to infinity a n cos n omega naught t plus bn sin n omega naught t, राइट? ये लिखते हैं. अब आपको समझ में आ गया कि ए नॉट ए एन दो हमारा सिग्नल एफ टी है, एफ टी विच इज फ्रॉम माइनस इंफिनिटी टू इंफिनिटी एंड इट इज ए पीरियोडिक विद टाइम टी नॉट. तो हम लोग ए नॉट को कैलकुलेट करते वक्त सिर्फ टी नॉट का ही यूज क्यों करते हैं? सो ए नॉट इज इक्वल टू व्हाट? आई मीन वी हैव ऑलरेडी सीन द फॉर्मूलाज एंड ऑल दैट. सो आई होप दैट दिस इज क्लियर टू यू कि हम लोग पीरियोडिक क्यों बोलते हैं कि पीरियोडिक सिग्नल का फूरियर सीरीज होता है. इज इट क्लियर टू यू ऑल ऑफ यू? पॉइंट सबको क्लियर हो गया? हेलो, am I audible or not?
Yes, sir.
Okay, so I hope that this point is kind of clear to all of you. Let's move on from here and let's try to understand. There is just one more thing that I would like to discuss here. Okay, so we have our ft, and can you see that ft is discontinuous at certain points, isn't it? ft जो है या ft नॉट t ही कोई देखो, ये isn't it discontinuous at certain point? Right? So it is discontinuous, yes, at certain point, especially at t naught and t naught by 2. But if you look at this right hand side, if you look at the right hand side, it contains only continuous signal, isn't it? One क्या constant one for all time, so that is continuous. Cos n omega naught t या cos omega naught t या उनका addition या cos कोई भी cos लो, sin लो या constant one लो, ये कोई भी signal डिसकंटिन्यूअस है? कॉस डिसकंटिन्यूअस है या साइन डिसकंटिन्यूअस है?
No.
नो, राइट?
No, sir.
Isn't it? So लेफ्ट हैंड साइड में हमारा डिसकंटिन्यूअस सिग्नल है और राइट हैंड साइड में हमारा क्या है? कंटिन्यूअस सिग्नल है, राइट? सो इसका मतलब राइट हैंड साइड और लेफ्ट हैंड साइड डिफरेंट है, isn't it? और बाकी पूरे टाइम के लिए भले एफ टी इक्वल टू दिस राइट हैंड साइड हो, isn't it? बट सर्टेन पॉइंट्स के लिए ये इक्वल नहीं है. ओके, एंड दिस इज द रीजन वाई फूरियर का ये जो पेपर था वो रिजेक्ट हो गया था. मैथमेटिशियन ने बोला कि आप लेफ्ट हैंड साइड में डिसकंटिन्यूअस फंक्शन रख रहे हैं और उसको बता रहे हैं इक्वल टू राइट हैंड साइड में कंटिन्यूअस फंक्शन. दे आर वेरी रिग्रेस अबाउट इट, मैथमेटिशियंस. ओके, तो बोले कि ऐसा नहीं चलेगा भाई, इस तरह के पेपर हम पब्लिश नहीं कर सकते, तो उसको भगा दिया फूरियर को. बट फूरियर थोड़ा रिच आदमी था, उसने बोला कि तुम पब्लिश नहीं करोगे तो क्या हुआ, मेरे पास पैसे हैं, मैं बुक ही छाप दूंगा. तो उसने किताब छाप दिया. लेटर ऑन इट टर्न्स आउट टू बी वेरी यूजफुल बिकॉज इफ two signals are almost equal at every point, infinite many points हैं between let's say 0 to ये सिग्नल let's say यहाँ पे मैं 0 लिख रहा हूँ, यहाँ पे 1, ये 2. So let's say -10 to 10 के बीच में आपके पास कितने पॉइंट है? इनफाइनाइट मेनी पॉइंट्स, राइट? उस इनफाइनाइट मेनी पॉइंट्स में अगर कुछ पॉइंट्स पे सिग्नल जो है इक्वल्स नहीं है तो उनको ऑलमोस्ट इक्वली माना जाता है. ओके, बट वी स्टिल लाइक टू नो व्हाट इज दिस राइट हैंड साइड इक्वल टू. ओके, सो राइट हैंड साइड की वैल्यू क्या है? तो राइट हैंड साइड इट टर्न्स आउट दैट इट इज कन्वर्जिंग एट हाफ वे. सो अगर लेट्स से दिस वैल्यू इज 1 एंड दिस वैल्यू इज 0, सो ये जो है राइट हैंड साइड क्या हो रहा है? हाफ हो रहा है वहां पे. इज दैट क्लियर? और अगर ये 5 था और ये -3 था तो वो कितना होता यहाँ पे, वो पॉइंट ऑफ डिसकंटिन्यूटी पे राइट हैंड साइड 5 + -3 डिवाइडेड बाई 2 1. आर यू गेटिंग माई पॉइंट? सो राइट हैंड साइड कंटिन्यूस है और उसका वैल्यू क्या है पॉइंट ऑफ डिसकंटिन्यूटी पे. दैट शुड बी क्लियर, इजंट इट? समझ में आ गया आप लोगों को?
यस.
और बिकॉज दे डिफर बाय दिस, क्योंकि दिस वैल्यू है, सो आफ्टर दैट देयर टर्न्स आउट टू बी ए जंप, और वो जंप हमेशा 9% ऑफ सॉरी एक ओवर शूट होता है या अंडर शूट होता है. और ओवर शूट और अंडर शूट जो होगा दैट इज एग्जैक्टली 9% ऑफ दिस जंप. ओके, कितना होगा? 9% ऑफ दिस जंप. जो गिब्स ने लेटर, और गिब्स वाज आई थिंक रशियन, तो वो रशियन मैथमेटिशियन था जिन्होंने बताया कि देयर इज ऑलवेज जंप इन द राइट हैंड साइड. आई मीन आई विल शो यू सम पिक्चर्स देयर, गिब्स फिनोमिना आगे जाके मैं बताऊंगा आपको. तो हमेशा जंप होता है. वो जंप कितने का, आई कैन नॉट ड्रॉ दैट प्रॉपर्ली, सो आई विल show you some simulation or something like that. So you will see that there will be jump here, and that jump is equal to 9% of this sorry, वो overshoot और undershoot होता है, और वो कितना होता है 9% of the jump. So let's say अगर यहाँ 0 है और यहाँ पे 10 है, तो 10 का जंप हुआ तो ये इसका कितना होगा 9%, यानी 10 into 9/100 दैट इज 0.9 का ओवरशूट होगा ऊपर, और यहाँ पे भी 0.9 का ओवरशूट होगा. इज दैट क्लियर? अगर ये 20 रहता तो वो 0.18 का ऊपर ओवरशूट यहाँ पे जाता, तो लेट्स से 20 है तो 20 में 1.8 करोगे तो कितना हो जाएगा 21.8 होता, और यहाँ पे वो क्या हो जाता 0 से 1.8 माइनस करोगे तो -1.8 रहता नीचे ओवरशूट. आर यू गेटिंग माई पॉइंट? So we will discuss that thing about when I will show you some pictures there on online or maybe some simulation, and then you will understand this. Okay? Is it clear? For now, you just go through this, try to understand these formula. From the next class onwards, we will learn how to compute this A naught, AN, and B main effectively, which do it as fast as possible. Okay, that is the kind of main theme here, because in the examination you have to compute this, and computing this A naught, AN, and BN takes hell lot of more time. I mean बहुत ज़्यादा टाइम लेता है, जो बहुत ही टेंशन की बात है. एग्जाम में फूरियर सीरीज की प्रॉब्लम अगर आप सोल्व करके मैथमेटिकली करने चले गए, so it is going to take 10 to 15 minutes of time, and that puts kind of pressure on students. Okay, so I hope that all these things are clear. Now I'm going to end this session, and we will discuss the same thing on Friday. Is that okay with everyone? Should we discontinue this session now?
Yes.
Yes, sir.
Okay. Because there is no light, so I mean, I'm kind of okay. So I'm going to end this session now. All of you, please.